Last year, a student of mine up in Queensland was blown away that protons and neutrons were actually made of something else. So, Lukyn, this one's for you. Elementary particles are those that are fundamental matter, not being composed of smaller parts. Students at a junior level are taught about the particle theory of matter. Then they are introduced to the idea that the particles are actually these things called atoms. Delve a bit deeper, and atoms aren't indivisible, but are actually made up of 3 subatomic particles: protons, neutrons, and electrons. That's where most people stop, and it's where we reach the topic of this video. You see, electrons are elementary particles. They're a type of lepton, one of the fundamental particles of the universe. But protons and neutrons aren't elementary particles. They're actually composed of even smaller particles called quarks. Quarks are elementary particles, not being composed of smaller constituents. They are a fundamental component of the standard model of particle physics, which is the current theoretical framework that describes the fundamental particles and their interactions. There are 6 types or flavors of quark: up, down, strange, charm, bottom, and top. The up and down quarks are the lightest and most common in ordinary matter, making up protons and neutrons in atomic nuclei. Protons are made up of 2 up quarks and a down quark, whilst neutrons are made from 2 down quarks and an up quark. Quarks carry fractional electric charges. Up quarks have a charge of plus 2/3, whilst down quarks have a charge of minus 1/3. With this understanding, it should make sense why protons have a plus 1 charge and neutrons are neutral, with no charge. Protons have 2 up quarks, giving a charge of plus 4/3, but they also have a down quark with a charge of minus 1/3, which brings the total charge to plus 1. Neutrons reach a charge of minus 2/3 with their 2 down quarks, but then the remaining up quark adds plus 2/3, bringing the total charge to 0. Quarks interact through the strong nuclear force, mediated by particles called gluons. This force is responsible for holding quarks together within hadrons, which are particles made of quarks. In fact, quarks never exist in isolation. They are always found in combinations of 2 or 3, due to a phenomenon called confinement. 2 quarks make a meson, and 3 quarks make a baryon, like protons and neutrons. The strong force gets stronger as quarks move apart, making it energetically unfavorable to separate them. As a result, quarks are always bound within larger particles. Quarks can also change from one flavor to another through the weak force, which is responsible for processes like beta decay. This is also important in the process of nuclear fusion in stars, when 2 protons combine to form deuterium, a form of hydrogen containing 1 proton and 1 neutron. So there you have it, quarks in a nutshell. Now you've gone further than just the standard protons, neutrons, and electrons, which, as I said earlier, is where most people get to.
If you like this video, punch that like button. If you want to see more videos, smash that subscribe.